Hello students, this is Stevens and Geese galvanometer to study the variation of magnetic field along the axis of a circular coil carrying current. Now let us see the various components of this apparatus. This is Stevens and Geese galvanometer. You can see this is the Stevens and Geese galvanometer, and we have various terminal here. This is the common terminal, and here we have 5 written over here, which shows that when we connect here, then the 5 turns will come in the circuit, and again we have 50, and maximum we can have 500 turns. And this is the circular coil carrying a maximum of 500 turns of copper wire. This is the magnetic compass. This is the reversing key or commutator, and it is used to reverse the direction of the current. When we will move in this say in the right direction, then the current will move in one direction, and we will move in the opposite direction, then the direction of the current will be reversed, right? This is the key, this is the ammeter, this is the battery, and this is the rheostat, right? Now let us see how the connections will be made. Now this is a circuit diagram, and for circuit diagram you can see the one end of this tangent galvanometer has been connected to the one end of the reversing key or commutator, and the opposite end of the commutator has been connected back to the tangent galvanometer. The remaining two terminals, one terminal is connected to the battery, and the other terminal of the battery is connected to the rheostat, and from rheostat we have ammeter, and from ammeter we have key, and from key we have the fourth terminal of the reversing key, right? So you can see that the one end of this commutator, of tangent galvanometer has been connected to the reversing key. The other end has been connected back to the tangent galvanometer. And amongst the another two ends, one end has been connected to the battery. You can see this has been connected to the battery. The other terminal of the battery has been connected to the rheostat, right? And from the rheostat we have connection to the ammeter, and so this end of the rheostat has been connected to the ammeter, right? The other end of this ammeter has been connected to the key, and the other end of this key has been connected back to the fourth terminal of the reversing key, right? So from ammeter to key, and then from key to the fourth terminal of the commutator, right? So students, in this way the connection will be made. And students, after making connections, we have to set this Stevens and Geese tangent galvanometer along the magnetic meridian, right? And for that, we have to make certain adjustments. The first adjustment is that we have to rotate this compass in such a way that the 0 0, you can see on the both ends we have 0 and 0. This 0 0 it should lie along the axis of this tangent galvanometer, right? So 0 0 should be in this direction, and 90 should be in this perpendicular direction, right? So I have placed 0 0 along this direction and 90 along this direction, right? And students, after that we'll rotate this apparatus till these aluminum pointers they lie on the 0 0 direction, right? Now students, you can see the pointer is lying on the 0 0 direction, right? And therefore students, we can say that our this magnetic compass or this magnet, this black color thing is the magnet, and this red dot is showing the direction of the north pole. So we can say this has been aligned in the magnetic meridian direction, right? And so the arms of the tangent galvanometer are in the eastward direction, and we can say this magnet is along the north-south direction, right? So students, this is the east-west direction, and this will be our north-south direction, right? And so students, in this way the setting will be made.